Trenching and excavation, man, this one drives me batty. I think any of these fatalities are just absolutely preventable. And I see, when I see this come through the news, it just makes me sick to see, man, we killed another contractor. A huge percentage of them are in Utah County. If you see a story come through, it's like, oh, another one in Utah County. And I know there's a lot of construction going on down there, but it's frustrating. All right, this one's rough. Don't watch it. You don't want to see people taken out. Yeah. And that's what he does as he pulls up. Was that the right decision? No, it was probably the one chance those guys that were in there had to survive was that air pocket and anyway. Oh. And then he starts digging. Yeah. It's just frustrating. Now, how important is it to think through that ahead of time? I mean, we've had that same thing. We can look at that and say, that's in China. But has that same thing happened in Utah? It has, and people have cut their companions, their coworkers in half, decapitated their one. I think it was two brothers working together, and decapitated one, and is probably done anyway. But we got to think about, what are these steps if something happens? But more importantly, let's not get to that point. Let's just do it right to start with. All right. So talk about this stuff ahead of time. Let me get to, this is dangerous. When fatalities happen, a good percentage of these are dealing with trenches. Trenches and falls are the big ones in the construction industry. And it can happen to any one of us. I remember being a kid out on the farm, and we were digging trenches, installing irrigation lines and things like that. And I had no idea what a trench box was. I was just a, 10 or 12-year-old kid out there plugging pipe together with the old man. And I remember the trench collapsing in around us. We're going along, and I'm like, Dad, this is a little sketchy here, isn't it? He's like, well, hurry up, we're getting behind the backhoe. And probably, if you've been around long enough, we've probably seen that, and we've probably done it wrong at least once or twice. Let's make the commitment today that we're not going to do that wrong, because it can happen and it will happen. It's just a matter of time until we're in the wrong place at the wrong time. I had one a couple of years ago. My brother calls me and he's like, hey, can you come help me? I'm like, what's going on? He's like, my trench is collapsing. I'm like, you're not in there, are you? And anyway, it happens. All right. So this is an OSHA standard. Once again, that's what we're talking about, is this OSHA standard. And it basically says, if you're in an excavation with certain limits on it, you have to have protections in place. Okay. All right. So what's a trench? It is less than 15 feet in width. What does it mean if it's 16? Well, it's an excavation. So what's the idea with that? Well, excavations are still dangerous, but what makes a trench more dangerous? There's another wall. So when it collapses, it crushes you against the wall, it buries you. If I'm, here, let's say this is all excavated there, and that collapses, well, the chance that I get thrown away or I'm safe at the end of it is a lot better than in a trench. Okay. We have to have a competent person, just like we talked about in confined space. There's got to be somebody designated that understands the hazards and has the authority to take action on it. If it's deeper than 20 feet, things get really dicey. Okay. The physics of a trench deeper than 20 feet get really funky. And so in those cases, we have to have a professional engineer, a registered professional engineer, design this excavation. Okay. Every trench has the potential to kill. Does a 3-foot deep trench have the potential to kill you? It absolutely does. And we've had some near fatalities within the trust pool in people in seriously 3-foot deep trenches. Had a guy bent over installing some conduit, and that 3-foot wall collapsed in, folded up his pelvis, and just, did massive internal injuries. Just a, terrible situation in a 3-foot deep trench. So we've got to respect any excavation in the ground. Gravity is going to win. It's going to win for all of us. Eventually, we're going to be horizontal. Eventually, every one of those trenches are going to be horizontal, and those mountains up there are going to be horizontal, given enough time. Okay, gravity's going to win. Another bad one here. Ugh. Don't watch it. You don't want to see people taken out. Yeah, done deal, right? Concrete wall comes on top of you. All right, so competent person. Knowledge, they need to identify the hazards. They need to have the authority to take action. So we designate a competent person. Now, many of your organizations will have stop work authority for anybody on the job, right? If somebody sees something that's not right, hey, I think we're going to hurt somebody here. Anybody can throw their hat in the air and say, whoa, let's step back and look at this. I'm worried about this, and then figure it out. That's good. I recommend that for everybody. Give everybody stop work authority if it's for a safety reason. But we have to designate that competent person who's going to take responsibility. So every excavation job should have a competent person designated. Okay, and one of the things that I'll send out in the email is there's just a sheet for inspecting your excavation. That competent person should have that in their hand. Okay, that's kind of their way to track all of those things and designate them as a competent person. Okay, so they need to be there anytime that there are employees in the trench. Okay, they need to be there. They need to determine the appropriate protection, whether it's sloping, shielding, shoring, whatever it may be. They're going to make the call on that. They do soil tests. How often does your soil change here? Is it all pretty standard out here? You're far enough away from the mountain. It's pretty stable. A lot of places I go, they're like, yeah, it's every 5 feet. You guys online probably aren't hearing that, but the example was North Salt Lake is a totally different strata, not that many miles away. But you get out here in Woods Cross, it's pretty standard. Is it clay soil here or mostly clay? A lot more stable than other places. When I do this class, a lot of times people are like, oh yeah, it's every 5 feet. We have a different soil type. And so staying on top of that for the competent person, that's a job in and of itself, because if I go from clay to cobble rock, river rock, it's a whole different animal. Yeah. All right. Performing inspections prior to the start of the workday and as needed, and evacuate people if needed. If the competent person says, uh-oh, it looks like we might have an issue here, even if it's in a 3 feet deep trench, they have the responsibility of saying, get out, let's get a trench box, let's do something, slope it, whatever it may be. All right. And be aware of the other hazards. Now, are utilities always where they're marked? I said my son works for an agency, and he's like, oh yeah. He called me one day and he's like, we cut a fiber line. I'm like, oh, that's expensive. I'm like, did you have it marked? Yeah. He's like, it was nowhere near where they had it marked. He's like, we did it fine, and and the lines were still, they were like 20 feet away from where it was supposed to be. All right. So before we dig, make sure we mark the utilities. Sometimes it's you marking the utilities. Sometimes we have others out there for others. How far back from those marks do I need to stay? 2 feet on either side, right? So what do you do in that 4-foot section? It's hand dig in those areas. Can you still strike a utility with a shovel? Yeah. Okay. Surface encumbrances. What the heck is a surface encumbrance? There's your stuff on that. What is a surface encumbrance? We got it properly shored though, right? Yeah. A surface encumbrance could be asphalt, overhanging asphalt, curb and gutter. It could be a building, something like that that's on the surface that could collapse in on us that may need to be shored. So we've got to take steps to shore those up. Okay. They were waiting for this one all day long. It's a boulder. Impressive. All right. So the other thing that we need to be concerned about is traffic. Most of the work that you're doing is going to be out in the right of way somewhere. So how do we control that? Well, proper traffic control, set that up right. Does that mean people are going to be smart? Does that mean they're going to stay out of your trenches? I've worked at the trust long enough and I've read enough claims to see that people are dumb. And even with barricades in place, they're going to drive into your trenches. So let's go the extra effort on those things. At the end of the shift, I'm not done with the job. I need that trench open tomorrow. What do? Cover it, plate it, or fill it back in. Don't leave an open trench, an unattended open trench. I got to tell you, if you leave an open trench, people are going to drive into it, or they're going to fall into it. Kids are going to fall into it. It's a massive liability issue. So plate it or fill it back in. It's easier to dig the second time, I hear. All right. Falling loads. Oh, just a important consideration on that. You guys are working around backhoes. You're dealing with pipes, installing things, fixing leaks there. Do you need to wear a hard hat in an excavation? The answer is yes. I got potentials. I've got overhead loads there. It's a construction site. You got to wear a hard hat. But here's the big thing on this. You got to watch yourself around backhoes and excavators. I see way too many people getting fingers smashed, losing fingers. I saw one come in, a guy got his ribs broken. I didn't want to I wasn't pointing any fingers. I wasn't pointing any fingers. But I've seen dozens of those come through. And when I see those, what do I say? We're too dang close. We're not giving our excavators enough space. And if an excavator operator is there saying, "Get in there," we need to have a talk about that. Don't put yourself in that situation. I saw one come through. A guy's digging a grave, and a guy standing nearby, and he got his ribs broken by getting hit by the bucket on the backhoe. You're too dang close. Do you need to be that close for digging a grave? No. I'm sorry. We've got time. We can do it right. We can do it the safe way. Give yourself space around that heavy equipment. Now, to the backhoe operator's credit, they can be the best hoe operator in the world and have a bad day. Or they can have problems with their equipment, bubble in the hydraulics. You can have things break, and it's not going to work. So give yourself enough space on those. Okay. All right. And traffic control, right? All right. Wear those vests. as well. You know, we may have, or reflective clothing, we may have gotten away with that for a long time because it wasn't nearly as crazy. But I'm here to tell you, people are not paying attention when they're out there driving. You've got to keep yourself visible. And when I talk about that, that really terrifies me. Every day I open up my news app on the phone and look at what's happened. And I don't want any of you guys to be dead out there. I don't want you to be hurt in something like that. And I know you're exposed to it day in, day out. You got to work double hard to stay visible and stay aware of what can happen out there, because people are texting along, they're doing whatever it is that's besides watching where you guys are. So work really hard to stay visible and protect yourself. If you got to park a dump truck, or you got to put something in the way to give you that extra level of protection, do it. Okay. Let's see. Got back here. Yeah, I think we covered all that. It says on their test atmosphere. Is there a potential that we could have a hazardous atmosphere in an excavation? Like what? Carbon monoxide. Yeah, so I got a compactor going down in a trench or something like that. I definitely could do that. Anything else? Gas off from what? Oh, gas. Oh, like a natural gas. Oh, a gas saw. Oh, yeah. I thought you were talking about a off-gassing from something else. But you could have a utility line, natural gas line leaking. Sometimes it's just the soil itself can release. Oh yeah, because of refinery releases over the year. You open that and there's tetrachloroethylene or whatever it is that might be in there. Some places it's just naturally occurring. You can have carbon dioxide come out of limestone when you start digging. Okay. All right. So what's soil? Soil is a combination of a lot of things. Is there air in soil? Yeah, can be. Organic matter, breaking down organic matter. But at its base, it's made out of rock, really small rock. Sometimes it's large rock. Clay is stuff that's been broken down a lot more, and it gets down to a really fine content or fine consistency. All right. So soil is heavy. It weighs about 100 pounds per cubic foot. How many cubic feet in a cubic yard? Ooh. That's a tough one. 3 by 3 by 3. 3 cubed. 27 cubic feet times 100 gives us almost 1.5 tons in a yard. So if that yard of soil collapses on you, guess what? You're toast. We're basically dropping a car on you when that collapses. So that's why it's so serious. This guy that passed away last week, and I apologize, I just pulling something from the news, apologize if I don't know if anybody's close to this person or not, but the guy got buried. They dug him out. And then he crashed and died. Why? Massive internal injuries. And anytime we get this massive pressure there, I think he maintained consciousness until they pulled him out, and then he just crashed and died. But the pressure causes internal injuries, and just the pressure itself, you can bleed out when they take that off. That's another reason why we want those emergency responders there if an accident ever happens, because they have ways to help prevent that when they take that pressure off. If we just dig somebody out, it can be like that, where they just instantly called hypovolemic shock. It's all of your blood drops out, and it's just basically like the pump isn't primed anymore. Okay. All right. So we take all of this weight, I dig a trench, and I've got this wall there, and I've got all the weight. What's going to be the weakest part of that trench? Top, middle, bottom? Kind of depends, right? Top's always a little bit loose there, but what's going to have the most pressure on it? The bottom's going to have a ton of pressure just from gravity. And so it has a high potential to fail there. But it depends. If I've got clay up on top and I've got gravel down on bottom, what's going to be the weakest part? Well, that gravel is going to be the weakest part. And I could invert those. And that's why your eyes are so important, why the competent person is so important in reading a trench. And you guys have been doing this a long time, and you can probably read a trench a lot better than I can and know which one's going to fail. But that's the reality is there's no exact science to this. It's every trench is different, and you've got to be watching for what those risks are. Okay. All right. We'll just let this play for just a second here. What is the purpose of a trench box? Is it to keep the walls up? It's to keep the workers safe. We know it's going to collapse eventually, so we want to keep people safe. A lot of times we see there'll be a little subsidence at the bottom of a trench. What does that do to the overall trench? Well, it weakens it, right? The bottom of the trench falls away. There's no base, there's no foundation under that wall. Sometimes collapses are a multi-collapse event. I get that little kick out at the bottom, but I just keep working because we got to get this pipe in. And then there's a secondary collapse, and it pushes me against the wall and it pins my legs. And generally I'll have at least one person in every class I teach trenching that's been buried. And some of people, they're buried up to their ankles. And I'll ask the question, you could just pull your feet out, right? The answer is no. The weight, the pressure that is involved with that, you're there. So I'm buried into my ankles or my knees with that secondary collapse. Now what? Do we jump into the trench and start digging me out? No, because what happens is when I go to jump into that trench, I may cause the third collapse. And it might be both of us that are totally buried at that point. Now, am I going to throw a shovel into a guy? If I ended up, we're not going to do that, right? Because we're going to do it right. But let's say I came on that situation, and there's a guy buried down in there, and he's up to his ankles or up to his knees. Yeah, I'm going to give a shovel to that guy, give him a chance, right? At least we'll be able to find the shovel as we're digging him out, and it'll let us know that we're on the right track to finding the guy. Okay. All right. So various different types of collapse. Sometimes we get our spoil pile too close to the edge. How far away should my dirt pile be from the edge of the trench? What'd you say? 2 feet? At least 2 feet from the edge of the trench. Why? Weight, right? The more weight I have on there, the more it's pressing down on the edges of the trench. The other thing is sometimes it can just slide. So that's the spoil pile slide, where it just slides off the top of the trench. Similar to that is the lip slide, where that very top part of the trench is kind of a lot of times gets broken up as you're digging it. That's that lip that will slide in. The belly slough is one that we might see. You said North Salt Lake's got variable soils. So sometimes I've got layers of soil. Maybe I've got clay on top, and then I've got a layer of gravel, and then there's clay in the bottom of the trench. What's the weakest part? Well, the gravel is. We get this belly slough where the middle of the trench kicks in. Now what do I have? Even if it didn't bury the guy down in the trench, they got buried to their knees. Now what does that trench look like? Really scary, because I've got an overhanging clay layer up there. And if people try to get in, or when the emergency responders come, what are they going to have to do before they try to rescue the guy? They got to shore it up. How easy is that going to be to shore up a trench that has an overhanging layer and then this belly that's fallen out? It's really tough, and it's going to take a lot of time. So the guy that's buried down in the trench, what do you do with him? Throw him a rope and tie a rope on him. Why? It's easier to find his body, right? We're not going to be able to pull him out, because we'll pull him in half if we try to hook on to him and pull him out of where he's been buried. So we're gonna throw a rope to him so we can find him, but we got to keep people away. We got to keep equipment, turn off the equipment and those things, because we don't want that vibration to cause that secondary collapse to happen. All right. Oh, this one drives me batty. You can tell when it's a real video, right? Because they pan away, they miss the money shot. Oh, just drives me batty. All right. So let's talk briefly about types of soil. I have 4 soil types. One is solid rock. Now, we don't generally see a lot of that in most of our areas, but you go down to Moab, you can have slick rock, right? I've got sandstone. That's the most stable soil we have, right? If I can chip a trench through that solid rock, it ain't going anywhere. Okay. Then we have gravel, sand, and clay. They're the general types of soil that we see, and there's a lot of in between between those different types. Okay. We want to classify soil, and this class is not how to teach you how to be a soil scientist and go into the minute detail, because, like I said, there are a lot of different soil types. But let me go back to this one really quick. We said solid rock is going to be the most stable soil type. Of the other 3, which will be the most stable? Clay. Will it always be the most stable? No. Why? What can I do to clay to make it unstable? If I get it wet, it can turn to jello. Okay? All right. So we're going to classify soil, though. And we have solid rock, and then we have 3 classifications, type A, B, and C. Which is the most stable, A, B, or C? Type A is the most stable soil. C is the least stable. And here's the rule. Treat everything as if it's type C soil, and then you're covered. Okay? When do we use type A, B, or C? The only time I use that, besides just my general knowledge of, hey, this is a type C soil, this is a lot more at risk for collapse. The only time I really use this information is if I'm sloping. So if I dig a trench and I want to use sloping as my protection, I'm going to, if it's a type C, I slope it 1.5 to 1, and then I'm covered. So of all the time we spend on this, that's really what it's all about. Type A, B, or C is my slope. It has to be a lot flatter on type C soil. Okay, so always treat it like that. But we do want to identify it, the different types. So I do at least one manual and one visual test. A visual test, I look at it, and I'm at a gravel pit, and I can see, cobble rock rolling out. What is it? Well, those particle sizes are really big. The bigger the particle size, the less stable it is. Okay, so you think of that compared to clay. You can't even see the particle size in clay because it's so small. All right. If there's water there, then it is less stable. I can't have type A and have water protruding or coming out of this soil. Cracking or spalling. Cracks, you see cracks in the material. You can see in this picture here, there are little particles, and spalling is if I get stuff flaking off. If it's flaking off like that, then I know it's a less stable soil. All right, so particle size. Gravel can be type B or C. What's the difference? It's angular gravel versus round gravel. What's the difference between river rock or, you know, gravel right out of a gravel pit and crushed gravel? How does it it what? More edges, and so it locks together, and so your angular gravel can be type B. It's a little more stable. But once again, I go back, treat everything as type C, and then we're protected. Okay? Sand, you guys know what sand is? Then we have silt and clay, and so our particle size gets smaller and smaller on those. All right. Oh, another one. That's when actually they don't get buried, but. I think it's diamonds, yeah. And the crazy part is then, and he's just going, he's just digging, and everybody has to bail out. And then they dive right straight back in. Is that amazing? Oh. Or how many people that weren't coordinated. So here's some warning signs for soil. If I see cracks in the soil, that's just a warning sign that says this is less stable. Spalling, the little flakes coming off. Sloughing, what does that mean? Yeah, it just slides out, kicks out of the bottom. Heaving, what does that mean? There's pressure coming on that. Boiling? What's boiling? Have you ever seen at the bottom of a trench, you may have water in there, and you'll see little particles bouncing around? What's that telling you? Telling you, I got water, I've got hydrostatic pressure there forcing water into that trench. What does that tell me? That's a huge warning sign, right? There's, not only does this trench want to tip over because of gravity, but I got water pressure forcing through here. And as that water moves, it's weakening that all of that soil, okay? Water equals danger in a trench. All right, so we do, so those were visual tests, then we do manual tests. We want to test the cohesiveness of the soil and the compressive strength. Cohesive means how sticky is it? Okay, so I've got my, I'm not going to get Play-Doh on my hands today. It stinks. If I've got Play-Doh, is it cohesive? Yeah, super sticky stuff. If I've got a handful of sand, is it cohesive? No. Okay, so that's kind of the ends of the spectrum is how sticky is it? Will these particles stick together? Sand is not going to be stable because it's not cohesive. Okay, then we have the compressive strength, which basically says how strong is this material if it has pressure on it. So if I cut a wall of a trench, I know it's got pressure on there. Will it break? Okay. So take this same Play-Doh, and I want to do a compressive strength test on that. We do the thumb test. And I push my thumb into that clod of Play-Doh. Does it have a whole lot of strength? No, it's easy to shove my thumb right in. Actually, this Play-Doh's been around for a while. If I pulled it out, it might be rock hard. But it's not going to have a lot of compressive strength. Compared to, we go out and we have some heavy clay here, dry heavy clay, and I take that and I try to shove my thumb into that clod. I can't even dent it with my thumb. Okay, that's one of the tests that we can do, is called the thumb test. I thought I was doing the thumb test first. We'll talk the thread test. If I take this Play-Doh, I can roll it into a thread, about 1/8 of an inch. And if I can pick up about 2 inches off of the table without it breaking, we'll say that is a cohesive soil. Okay. Another test that we do with that is the ribbon test. And I do a similar thing. I make I roll out a little bit bigger roll of this, and then I start squeezing it, making a ribbon out of the soil, and let it drip over, let it roll off the side of my hand. And if I can get a couple of inches hanging off the side of my hand, then that's a cohesive soil. Okay? And just go back to the other side. If it's sand, is that going to work? It's not going to work. Okay? So you'll get it if it's cohesive soil. You grab some in your hand and you start working it, you'll get an idea pretty quick whether this is cohesive or not. Okay? The thumb test, like I talked about, put pressure on it. The thumb test is good for just a quick qualitative test, but it doesn't give me, everybody's thumb's different, right? Everybody gives a different amount of pressure. And so we have tools that we use for that. We call this a pocket penetrometer. And what that is a spring-loaded, you can see this moves. I will put this little red band down here, and I'll push it into the clod. And on here, about a 1/4 inch in, there's a red line. And I need to take that and push it into the clod until it penetrates to that red line. When I do that, it's going to put pressure on that. And then I'll look, and it says 1.5. 1.5 translates to tons per square. Let's see. I better get to the right one. Tons per square foot. So with type A soil, it's 1.5 or greater tons per square foot. Okay, super easy way to read it. If you're the competent person, you should have one of these. Okay, on your excavation sites, I would have one of these there. OSHA shows up, and they say, "Hey, who's the competent person?" And then the competent person walks out with a pocket penetrometer and their sheets that showing their inspections. It's a good day, as long as you got a trench box in, right? Okay. All right, so that's an easy way to test the compressive strength. There are other ways to do that as well, but we won't go into those today. It's not a type A soil. Okay, so going back to our reading, so 1.5 tons per square foot and above is a type A soil. Okay, in between 1.5 and 1/2 ton is type B, and less than 1/2 ton of pressure on that compressive strength is a type C soil. Okay, it's not type A if it's fissured, if it's got cracks in it, if it's subject to vibration. You jiggle this stuff and it starts turning to jello. If it has been previously disturbed, how much of your soil that you're digging has been previously disturbed? Most of it, right? So that's why I just come back to treat it like type C. You know, I'll go through the training. We talk about, well, this is type A, and that'll help you feel a little bit better about your trench. But if we treat it all as type C and we handle it appropriately, then we're protected. If water's there, it's not type A. Okay. Vibration is also another big factor, and particularly out in an area like Woods Cross where we are, is this soil subject to, they call it, losing my mind, in earthquakes, liquefaction. Is this subject to liquefaction in this area? Yeah. You know, it was funny, back in March when we had that earthquake, we were all in lockdown. I was working from the home office, and that earthquake hit, and I was like, wow. And I looked and I'm like, well, nothing's breaking. This is kind of cool. And then I talked to some of my coworkers, and they lived in an area where it was much more subject to liquefaction. And they were terrified of this earthquake. They were like, everything was falling off the shelves. Everything was shaking around, and their kids were freaking out. And they were terrified of what happened in this earthquake. And that's when we start talking vibration, that's really what we're talking about. Is some soil, when it's subject to vibration, will just turn into jello. Okay. All right. So so we talked about all of this stuff. I'm gonna jump into the next. Ooh. That's why. I hit that one a lot. Stay visible. He had his stuff on and he still almost died. We had one a few years ago, fire department, out on a bad wreck on the freeway, in wintertime, slick roads, foggy conditions, and a semi comes barreling out of the fog, going fast. And they're standing out there trying to deal with the wreck. And this firefighter backs up to get out of the way, and he backs into the fire engine. And he's standing right next to the fire engine, and the semi blows along and runs over his feet. This guy was a few extra Big Macs away from dying, right? You know, he's sucking in the gut so he doesn't get, anyway, just amazing that we didn't kill him. Got to stay visible, do what you can to protect yourself. Really? Wow. Close. Yeah. And that's why I hit that one on and on, is I just don't want to see, I don't want to see that claim come in. I don't want to see that news story when one of our folks ends up getting hit. Okay. All right. So now we've taken a look at our soil. We have to come up with some options to protect ourselves. The OSHA standard tells us that at 5 feet in depth, any trench, we have to have protection in place, some sort of protection. Sloping, benching, shielding, shoring, those are appropriate protections. What about less than 5 feet? The OSHA standard says that as long as inspection by a competent person says there's no chance of a collapse, then we don't necessarily have to have that. But is there a chance that we use a trench box or use shoring less than 5 feet? The answer is yes. And it could actually happen quite often. Think about, what's the general trench that you dig in public works? Water leaks, right? Is that a risky trench? It's wet. Generally previously, well, it's going to be previously disturbed, right? Because I got a pipe down there somewhere. There's a lot of things that go into that. So is a 4-foot deep trench safe? Probably not. Indication, you know, if I'm the competent person, I'm saying it's wet, it's previously disturbed, there's all kinds of bad things here, I'm putting a box in there. Okay? All right, so let's talk about these things. Uh-oh, here we go. I think you can make it. All right. So 4 feet, 4 feet and above, or deeper, we're going to be let's see, at 4 feet and above or deeper, we need to have something to help us access that trench, meaning a ladder, a ramp, or something to help us in and out. Okay, under 4 feet, I don't have to have that. I can climb in and out. Okay. Now, if I've got a ladder and I've got a trench box in there, where does that ladder have to be? Can I have it outside of the box? No, I've got to use that from inside the box, so it's not exposing me to collapse. All right. I can't remember what that one was. Oh yeah. All right, and an appropriate protection for crossing trenches. Okay, here's the OSHA standard on this. It says each employee in excavation shall be protected from cave-ins by an adequate protective system designed in accordance with paragraph B of this section, except when it's in entirely stable rock or Excavations are less than 5 feet in depth, and examination of the ground by a competent person provides no indication of a potential cave-in. So competent person is essential on that for the less than 5 feet. Questions? It's better with sound, actually. It's that nice aluminum bat sound. Cling. All right. Sloping or benching. Now, the difference between sloping and benching is what? With benching, I'm basically, I'll dig my initial trench, and then I'll come up, I'll raise up, and I'll dig another trench along there, and then raise up. But with sloping, it's an actual slope. But the angle is the same for sloping or benching. So if I'm in type A, 3/4 to 1, type B, 1 to 1, type C, 1.5 to 1. Not going to spend a lot of time on that because we're going to call everything type C, slope at 1.5 to 1. What do you find if you are sloping 1.5 to 1? It's a big excavation, right? It generally is not going to work in most cases because it goes so wide. So there's if you go online, there's a website, trenchsafety.com, and they have a trench slope calculator, and you can put in there the width of your trench, the depth of your trench, the type of soil, all of that, and it will tell you how wide. It'll give you a diagram and show you how wide you have to go to get the proper sloping. Guess what trenchsafety.com sells? They sell trench boxes. Why would they put a sloping calculator on there if they're selling trench boxes? Because when you really do it right at 1.5 to 1, you're going to use a trench box. Unless you're out in the middle of nowhere and you got nothing but room. But you're going to be hauling, you're going to be moving so much soil that it just doesn't make sense. So the trench box or shoring is where you're probably going to end up. Can I do a compound slope? The answer is yes. So the example is this one on the top left. Maybe I've got type A soil down on the bottom. Oh man. Is that telling me it's time to be done? If I've got type A soil on the bottom and type C on the top, I could technically, your warranty expires on your, it's your, I thought it was your car warranty expiration. They're giving you a call. So I could have a compound slope, but what happens if the type C soil is on the bottom? Everything's got to be 1.5 to 1. Okay. All right. Yeah, we covered all that. See that guy crawling out? Whew. All right. So I talk about a trench box. The technical term is a shield. What does a shield do? It shields you from collapsing trench walls. They're a design engineered system. I can't go out in the shop and just weld something together and call it a trench box. So there's certain specific things that have to go into it, and it has to be engineered. Okay. Do they have to be made out of steel? No, they have some great light little aluminum trench boxes that are for, trenches of less depth, but they're lighter and easier to haul around. Let's just talk about a couple of things. Down at the bottom of your trench box, it's pointy. We call that a knife edge. What's the reason why we have a sharp edge at the bottom of the trench box? Yeah, the idea is the backhoe operator should force that box down in so those sharp edges dig down into the bottom of the trench. So if I have a collapse, that force doesn't cause the box to tip over or be thrown to the side into the occupants that are inside of there, okay? We have the sidewalls, they're heavy, beefy sidewalls. And then I've got spreaders in there. Generally, I'm going to have top and bottom, but sometimes there are some other designs where they don't necessarily have to have that. If I lose one of those, can I just go to the shop and get a piece of pipe? Now, once again, it's all an engineered system, even down to the fasteners that put everything together. If you lose stuff, go back to the manufacturer and buy the appropriate stuff, okay? So if I'm lifting this stuff around, that rigging that I'm using should be certified for lifting. I'm not going to go into putting these all together, but let's just talk about how do I use a trench. Oh, this one's actually pretty cool. And then it'll lock in place. And anyway, all right. So installing in stable soil, and really there's one difference between stable and unstable soil. I'm going to cut the trench, make sure my spoil pile's back at least 2 feet from the edge, lower it into the trench. I will force it down in so those knife edges dig in, and make sure we've got proper egress and all of that stuff. How do I move that? Let's say I'm installing pipe and I'm digging and moving the trench along, or the trench box along. The difference between stable and unstable soil: in stable soil, I just drag it forward. Unstable soil, I lift it up and then set it down. Okay? Can I move it with people in it? No. They have to evacuate that when I'm moving. Yeah. Yeah, I'd be a little nervous about that. Okay. I think we covered that. Limitations: if they're damaged, don't use them. And I know these things get beat up, and that doesn't mean scratched and stuff like that. But if I've got a damaged spreader, those pipes are bent, or missing parts, don't use those. I've seen places where there's a utility going where it's in the bad spot, and people will take a spreader out because it fits. Well, you're going to be clean when you're dead now, but you're still going to be dead. Okay. What's the appropriate box for the job? How do I select the right shield for the excavation that I'm doing? What's the height going to be? At least up to the top of the trench. I would prefer it to extend above the top of the trench, just for in case that spoil pile isn't, we want to have that 2 feet away, but so stuff doesn't come in on top of us. How about the width? Does that matter? Yeah. If I've got a 2 foot wide trench box and my excavation is 8 feet wide, no good, because it can tip the thing over. So it needs to be the right width for the job. When you get deep, when you start talking deep trenches, these shields have to meet. Well, there's a table that shows exactly what they have to meet, and it gets a lot harder to meet those requirements the deeper we get, and so they're going to be a lot bigger, heavier, et cetera, et cetera. For most of what we do in a public works standpoint, most of the time they're water leaks. They can be fairly small. Those little aluminum light trench boxes will work. That's what I would say is, when you look for shielding, I'd say, what are we doing all the time? What type of stuff do we need? Sometimes we're going to do a deep one. Well, that's what we'll go out and rent. We'll rent the right one for the job then. Okay. All right. Can I stack up trench boxes on top of each other? Only if they're designed to do that. And then they have to be pinned together so they don't slip off. So yeah, I definitely can, but they have to be designed. Can I use, let's say I'm going really deep, can I use a combination of sloping and a trench box? Answer is yes, but down at the bottom there, that trench box needs to stick up at least 18 inches above that point. I don't know if you guys online can see that, but this point right here needs to be at least 18 inches above. Okay, covered all that. Doing good. Ouch. You notice he started from the opposite side of that truck. He flew all the way across the inside of the truck and then out the window. All right. What about graves? Is that a trench? I don't know. I don't know if anybody that's on here has a cemetery. If you do, I just published 2 videos. The Gravedigger. Huh? I just published 2 videos on our YouTube channel last week on 1, cemetery safety, 2, cemetery risk management. You ought to check out the cemetery safety one. It's got a little Halloween bent to it. Anyway, I use this as an example because sometimes we'll look at that and say, well, it's just digging a grave. Is it a trench? Yeah, meets the definition of trench. Is it a dangerous trench? Yeah. Is it over 5 feet? 5 feet? Is it previously disturbed? In a lot of cases, we already planted grandma, and now it's time for grandpa to go in there. So it's previously disturbed soil. Is it wet? A lot of times those cemeteries are really wet. We like those to, the only place we put more water on is the golf courses, right? We want them to look really good. So why would you have to get into a grave? Square the corners up, right? So the vault sits down in there. Should I use a trench box? Yeah. Can I use a trench box and do the job? Probably not. So what can we do? Whenever somebody says, I can't, I want to look beyond and say, okay, well, how can we make this work and do it safe? Do it from outside. So long-handled tools. The other thing is if you look at this bucket in here, that's called a grave digger bucket. And you guys that don't dig graves are like, why are we talking about this? There's a point. It's a grave digger bucket, and it's the same width as a vault. So you take one pass, and it digs, and those edges on there are like knives. They cut a real clean edge, and then you can see how it's vertical. It doesn't take out much dirt in a scoop, but I can totally square up those edges. So there's a way to do this safer. You go out and you spend, I don't know, $1,800 on an implement, put a different bucket on there, and I don't have to put a body into there. That's a safer way to do it. So what's the point? Let's look at these things, whether it's trenching or confined space. I may be able to, maybe I've got a meter vault where I have to go read a meter periodically. Can I put a radio read meter on that? Is there a way, the next time we go and install a PRV, does it have to be a vault? Is there a way that we can build it above ground? That may not always be possible, but it might. Let's make it a room. Let's make it a little building that I can walk in and do my job and not have to put myself into a confined space. Is there a way that I can see what's going on to that confined space with a flashlight and some binoculars and check those things out? Let's eliminate those hazardous tasks if we can. Okay. All right. Shoring. We won't spend hardly any time on this because in most cases we're not doing it much. In shielding, we're trying to protect the people when the collapse happens. In shoring, we're trying to keep the collapse from happening. And so we do that by putting in shoring materials, plates on the walls, and then we use pressure in some way, hydraulic pressure to hold those walls up. Why do I want to keep the walls up? Well, sometimes those trench walls are underneath a building, or they're underneath, maybe there's a road that we don't want to have collapse, or there's an irrigation canal, or something that I want to preserve the integrity of those walls. That's when I would do that. Okay. In most cases, you're going to hire somebody, a contractor, to come in and either do the shoring for you or to do the excavation for you. So that's why I don't spend a ton of time on this, but let's just talk about a couple of basics on it. We install the shoring from outside the trench. Okay. So as I do that, here's a good example here of a portable shoring system. I hate this because my laser doesn't work on that, but you can see there's some ropes dangling there. So I can drop all of this stuff in from outside the trench, set it in place, and pump it up and put pressure in place before I ever put any bodies in there. Okay, so install it from outside and ensure it's appropriate for the type of work that we're doing. All right, one more video and then we're just about there. Oh, man. All right. So I will email out these sample documents. So this, I think these are the last 2 pages in what I'll send out, is a daily excavation checklist and a soil analysis checklist. Simple things, you can print them off front and back. And this is what the competent person should have. It will help them meet their obligations under this. Yeah, we covered that. And I thought we were down to our last video, but we've got more. There's this big rock block down in the bottom they're trying to lift out. Just about got it. Ooh. And wear your seatbelt. All right. We talked about confined spaces in there. Let's just talk accidents really quick. Same thing goes from what we talked about in confined spaces. Time is of the essence, and it's not on our side if somebody gets buried in a trench. How long does it take for the fire department to come out and stabilize a trench before they can even try to do a rescue? A half hour is more than optimistic. It potentially could be hours prior to, this is a body recovery. So our option is to do it right to start with and not get anybody buried in a trench. It may be too late anyway, even with fire department got there quickly. Do it right. Have that shoring and shielding in place, and be smart. Have your competent person and all of us being aware of what is out, what those hazards are in the trench. If you see something that you go, oof, that's a little sketchy, share that information. You're not the competent person. You go up, hey, I just saw this in this trench. I know we thought it was okay because it was 4 feet deep, but I got water running into that trench. Talk to the competent person. Say, hey, let's pull off. Let's get a shield into this situation. Just make a commitment. We're going to do it right, because you know what? No job is so important that you can't take the time to do it safe. Questions? Beefs? Anybody mad at me? All right. I think we've covered it. We had a break partway through. Anybody on Zoom have any questions or comments? Oh, I woke him up. Darn it. Oh. Blake, you got a few marks on your forehead there. All right, guys. Thank you very much. Appreciate your time. Be safe out there. And if you've got questions, come and give me a call, give me a shout. I'm happy to help. Okay. Thanks. Thank you.